Hello everyone, my name is Zhisheng Huang. I come from Taiwan Chaoyang University of Technology. My topic is the influence of the angle of feature point for indoor positioning by machine vision. This is my outline. Introduction. In the previous work, 3D scanner is used to obtain environmental features, and image processing technology is applied to achieve positioning function, but did not further analyze the accuracy of this method. In this paper, we will experiment with the proposed method positioning technology to understand the influence of its positioning. Indoor positioning method. Our camera is planned indoors and overlooks from top to bottom. There are 4 feature points, f1, f2, f3, and f4. On the forwards, every 2 of these 4 feature points can form a circle with C. The angle between the sum of these angles is the angle between the f1 direction and the f2 direction. When the location of f1 and f2 with the angle are known, the location of the camera can be r1, r2, r3, or any point on the circumference. A circular equation can be obtained by every 2 feature points captured by the camera. The possible position of the camera is on the circumference. We can get an intersection every two circles. In our example, we can get 4 intersections as denoted with C1, C2, C3, and C4 in Fig 2. The average of these 4 positions is the camera position, which is the positioning result. Simulation space, experiments, and results. We made a space of 90 cm times 60 cm times 30 cm, the simulation space. 4 colors on the 4 sides of this space are used as feature points. The camera we used is Ricoh Theta S, which is a camera that can take panoramic views. We placed the camera in 2 locations in the simulation space are point A and point B. Each position of the camera should image in 2 directions, and the image of 4 directions A1, A2, B1, and B2 can be obtained. We can easily find out 4 feature points from the 4 imaged by color features. The angles estimated by the 4 imaged to each feature point are shown in Table 1. When there is an angle is large, over 80 degrees, the error will be increased. Real space experiment and results. This space is room 218 of Chaoyang University. Room M218 of Chaoyang University of Technology, with a space of 7.1 meter times 6.8 meter. The location of the 4 colors paper are known: blue, green, yellow, and red. We randomly take 2 locations of the camera in this space as shown with point 1 and point 2. We shot 9 images in each position. We will adjust the camera's shooting angle in each time we shoot an image. Each image is calculated by the proposed method to obtain the angle of each feature and the positioning arrow. From Fig 6, we can see that there are two arrows greater than 20 cm, hash 4 and 5, where each feature point has an angle greater than 72 degrees, and another feature point greater than angle greater than 52 degrees. In hash 3, one angle is greater than 72 degrees, but the other three angles are less than 40 degrees. In hash 8, there are two angles greater than 75 degrees, but the other two angles are less than 30 degrees. From Fig 7, only the area of hash 4 is greater than 20 cm, where there are two feature points has an angle greater than 73 degrees, and even one of them over 80 degrees. Conclusions. According to the experimental results of the simulation space and the real space, we know that the angle between the feature direction and the camera shooting direction will affect the accuracy of the positioning. The image taken by the fisheye camera will be distorted and reduce the resolution, especially when the object is at the edge of the image, when the angle is large. In the case that there are enough feature points, the feature points with large angle can be discarded to improve the accuracy. At the same time, if we can understand the distortion features of the fisheye lens, we can also improve the positioning accuracy. Thank you for listening.